Hello, everybody. Thank you for joining us today. You are part of the almost 300 persons worldwide who registered to this webcast powered by Yole Developpment and KnowMade and dedicated to robotic vehicle technologies. Let me first introduce quickly Yole group of companies. Our different companies provides marketing and technology and strategy consulting, media and corporate finance services, as well as through our partners, reverse engineering and reverse costing, and IP and patent analysis. With a strong focus on emerging application using silicon or micro manufacturing, Yole Developpment, with its partner KnowMade, System Plus Consulting, and Piseo, has expanded and now counts over 80 collaborators worldwide. So our group of companies cover MEMS and image sensors, compound semiconductors, RF electronics, solid-state lighting, displays, softwares, optoelectronics, advanced packaging, manufacturing, power electronics, and energy management, as well as medical technologies. So my name is David Jordan, and I'm Global Sales and Support Coordinator for Yole Development. So before we start this webcast, let me give you some practical information. First, you have the possibility during the webcast to submit questions. You simply have to use the box at the bottom of the screen with the label Ask a Question. Today, we will answer as many questions as we can, and remaining questions will be followed up via email. Concerning materials and the contents of the presentation, please note that the presentation is already available and downloadable in the resources section of the webcast platform. And after the webcast, you will also receive an email with the link to the recorded session of this webcast. So today, Yole Development and KnowMade will share their analysis with you on robotic vehicle technologies. First, we'll start with Pierre Cambou, Imaging and Sensor Activity Leader at Yole Development. He will present you the market of sensor for robotic vehicles. Pierre, the floor is yours.
Thank you, David. So first, I will give you a short introduction to robotic vehicle. What we mean by the word robotic. So this graph is 2-3 years old now. We've explained that ADAS will eventually lead to autonomy through gradual improvement of cars, as we know. But another path exists, which is mainly followed by tech companies. And this is really the subject of this webcast. What kind of technology, what are the market size, what are the choices that are made and in the sensor, computing, and a special focus on LiDAR for the patent landscape from our partner KnowMade. So eventually, those robotic car, will happen on our streets. But today, we can have a few ideas of what they look like. So there was the robot from Google Waymo a few years back, copied by Mercedes in the latest smart edition. There are mainly sedans, so Toyota, for example, the recent partnership of Google Waymo with Jaguar, Baidu with BMW. And let's not forget, there is also, after the cars, we may see the same technology applied to trucks. So Auto, Embark are some of the startups that we see coming. And eventually this robotic technology will move toward aircraft. So Airbus has a demonstrator, and we've heard recently about Kitty Hawk also having a demonstrator. So some of the technologies that we talk about tonight will be applied also to those aircraft. So what's at stake in terms of market? There are a huge number at stake. So here, when we refer to the market that might be targeted by robotic technologies, we can aggregate cars and maybe taxis, or several trillions of dollars. But probably it's not today's market that are at threat. As for most disruptive technologies, this is really mostly out of current use cases that we will see most of the growth. So current non-car users will be targeted, and also new car use cases. So I will not go through everything, but okay, this is just to say that humongous numbers are and the market are so huge. It's an opportunity for service provider, but also an opportunity for hardware provider, such as sensors, computing, and vehicle. So now let's get to robotic autonomous vehicle technology. I cannot start this talk without mentioning the different fatalities that have occurred and impacted the industry, and wanted to reiterate a few statements concerning false autonomy that I've mentioned in previous reports. So on the left of the slide, you can see a state-of-the-art ADAS solution that is mainly a machine taking over a human driver in exceptional cases, such as imminent crash. So usually the machine overrides the human driver and completely overrides it in a complete autonomous driving solution on the right side of the slide. This is what we would see, for example, in a commercial application of robotic vehicle. So there are in-between solutions where some instances of AD or ADAS where human is supposed to watch over a machine, and this is what at Yole we've called false autonomy, and this is where we see a lot of accidents occurring these days. So here I try to explain that we've entered the death valley of autonomy, especially from ADAS solutions that tries to implement more and more autonomy, so from the top of the graph. So until level 2, no problem, and the overall implementation were okay. But then once we try to do more than just mitigate accident, then we get into trouble. And it's also the same with level 5 R&D. We've seen some problem with Uber, but it seems some other companies such as Waymo and maybe Cruise are moving out of the Death Valley and are now able to provide through level 5 autonomous vehicle. So let's talk about sensor technology serving. So first, sorry, the ADAS. So the ADAS approach from a typical manufacturer, or car manufacturer, you know, as the technology is more and more ready in the robotic side, some player may want to change and to address this new market. And I'm thinking mainly Mercedes, Nissan, and maybe Toyota and Volkswagen. Yeah, so concerning the technologies and the players in the field of robotics, so there is a typical technology suite, which is LiDAR, radar, camera, IMU, and a computing platform. And the names that we see is relatively high-end players such as Velodyne, Luminar, camera makers such as Elite Vision, FLIR, First Sensor. The radar seems to be automotive grade, so not much to look into this direction, but IMU and computing also is especially designed to address robotic vehicles, so quite high-end approaches that we see from the players. The numbers are also quite high, so in the range of 8 to 10 cameras, 4 to 10 LiDAR, and 4 to 8 radar. So then the volume of robotic vehicles that we'll see on our street today is in the range of a few hundred. By 2022, we expect in the range of 65,000. And 10 years from now, probably more in the range of 340K, and then 2032 is 1.2 million. So that's just for the vehicle. I'm not accounting the trucks and not accounting the aircraft. But in the end, we expect a few billions to be made by 2022. For example, 1.6 billion on LiDAR, and creation of complete industries. Within 15 years, we see tens of billions to be spent on those vehicles if, let's say, this market develops as quickly as we envision right there. So in conclusion, the transportation market, as we know, is on the brink of disruption. So clearly there is a race between autonomous driving from level 1 to 5, from traditional automotive manufacturer, and the other tech companies following the robotic approach. Until now, hundreds of test vehicles have been used, and we will see the development of large-scale operation probably starting in 2018 in the range of 10K vehicles. So by 2032, we expect robotic vehicle technology and market to grow exponentially and disrupt the traditional automotive market. So capital expenditure will be in the range of 300 billion, and it will be spent on vehicle hardware. So this revolution will not be limited to transportation of people. We'll see also transportation of goods, and also automated trucks, and probably also aircraft and transportation drones. So I will hand over the presentation to Johan.
Thank you very much, Pierre, for this interesting overview. Once again, do not hesitate to ask questions with the question button. We'll try to answer all the questions at the end of the webcast. Now let's continue with the presentation on computing and software for robotic vehicle, presented by Dr. Johan Tjuli, software and market analyst at Yole Developpement. It's up to you, Johan.
Thank you, David. Thank you, Pierre. Short introduction. We are hearing about AI since 5-10 years, but just a word to say that actually it's an old discipline. At least mathematical tools exist since the middle of the last century. So why this success? Why we heard about since 5-10 years? There is two major things. First is described on the left plot, where we can see the availability of powerful computing platform, which are cheaper and cheaper. And the second thing is directly linked to the born of internet with the availability of data. And why we need data? If we look at one method which is used since 5 years, which a lot of success, this method is named deep learning. This deep learning method is part of a machine learning, which is a vast a whole thing of mathematical methods in the artificial intelligence domain. And what is interesting is that this method is based on image or video, and it is used in many domains. Here you can see some an example for face recognition, for example, of a neural network. But there is a lot of many applications. For autonomous vehicles, we can distinguish these multiple applications, which are free space recognition. When a vehicle wants to change lane, for example, it needs to understand the world around and if there is enough space for the vehicle to move in. We use deep learning for traffic sign detection, for pedestrian detection, more generally for object detection, I would say, not just only pedestrian, for lane departure, for forward collision warning, and that's kind of the few applications we can see for the autonomous vehicles domain. To run this, we need data, and where is coming from this data? This data are mainly coming from cameras, mono cameras or stereo cameras, and these cameras, these data are then run. The software is run in something we call the sensor fusion engine. This is the heart of the computing in an autonomous vehicle. So we have plenty types of different data coming from LiDAR, from radar, and this is all compiled in the sensor fusion engine just for the car to understand the world around. Then there is another steps later for planners and for the vehicle control. But just the message of this side is that the sensor fusion engine is the most important thing the most important part of software and computing in an autonomous car. In terms of sensor, as I say, there is 4 different types of sensors: radar, LiDAR, cameras, and even ultrasonic sensor, but it's something quite different. It's not really used for the fusion. But the important point here on this slide is what I want to say is that all OEMs are using different solutions for sensor combination. And this is interesting. This is interesting because it lets a place for sensor company to come in to get into the place. And if we are looking at these 4 different examples, for example, we have Volvo, we have Ford, which are using a very different solution, and as well for the Audi A8 or for the Tesla. So just to say, sensor companies, there is a place to get in. In terms of software, this is interesting. I'm not saying that there was not software before autonomy, before we the reach for autonomy. I'm just saying that now there is place for startups because the software has a big value. If we are looking at this market map, for example, from the service provider to the sensors company, there is kind of a battle between the bottom and the up. Just to be clear here, as described by Pierre, there is 2 different parts. There is the ADAS domain and the robotic vehicles domain. And the value of software in the ADAS part is detained mostly by OEM and Tier 1s, but it's not true for the robotic vehicles, where we can see sensor companies that bring their own complete solution, and this is something that needs to be noted. Just to conclude my part, I want to insist on 4 points. The first one is that deep learning is the main software and AI technology which is used to reach autonomy, and there is other methods I didn't describe because it will take too many times, but just to say that there is deep learning, but there is a lot of different tools that are used. And because we have different types of sensor and a lot of sensor, the data flow is huge. So to treat that, we need powerful computing and a very dedicated hardware. This is important to say. Because we have a lot of data and because the algorithms are very greedy, the hardware needs to be completely dedicated for the fusion. The second point is more about the supply chain, which is already well defined and a bit static if we are looking at the ADAS segment, with the value from software is detained by OEM and Tier 1. However, startups and software companies can have a place in the robotic vehicle segment because all the providers want at least to be agnostics in terms of technologies. So they want the best for everything. The third point is about software. Software is continue to improve drastically, and the incoming of dedicated AI engines, so hardware completely dedicated to run deep learning, is very promising. It is very promising for three things. First, the ability to integrate and treat more data as input, so we can add more radar and more LiDAR, more data. Higher precision and faster decision making, which is obviously very important when we are talking about vehicles and safety. And the third thing is about the ability to treat very complicated scenarios, which is nowadays still a problem when we are talking about night, bad weather, downtown conditions, and another bunch of stuff which are very complicated to treat. And the fourth point is directly linked to what Pierre said about the accidents we saw the last months. It's something which already exists since the beginning of autonomy. Be careful of that. I'm not saying that it's new, but this is something which is very pushed by all the companies that are doing this race, is simulation. So this simulation is needed to tune the software, and will never replace the miles on the road, but it's something that it's very interesting to look at and need to be followed. Thank you. Paul?
Thank you very much, Johan. Now this is time for Paul Leclerc, Patent and Technology Analyst at KnowMade, to provide a patent landscape of LiDAR technologies. Paul, it's your turn.
Thank you, David. So after seeing the computing part and let's say the end of the line, we're going to go back at the beginning, and we're going to focus on the sensor, or more specifically on LiDAR technology, because as Pierre Cambou mentioned in the first part of this webcast, LiDAR exhibits a very interesting dynamic and is becoming a more and more important part of the automotive industry. And so to dive into the LiDAR and the technology challenges around this kind of sensor, we're going to use KnowMade's vision, which is based on patent analysis and IP strategy analysis. And in order to understand what technology trend and what is the position of the different players involved in the LiDAR IP landscape. So to this study, we have identified and selected about 6,400 patent families related to LiDAR for automotive. And if we look at the time evolution of patent publication through the years, we can see two different time evolution. The first is related to the beginning of the IP landscape, so around in the 80s, with the first patent published by Bosch, Denso, or General Motors. And these first IP players were really focused on developing the technology and asserting ADAS application. And so when you look after at the patent, the number of patent family publication per year, you can see that the flat is almost flat. And then in 2010, we have witnessed a first increase and a fast increase of the patent publication related to LiDAR for automotive. And this increase is very huge because the annual growth is about 20%, which is very unusual, very specific to LiDAR and not that common. So the question here that is why there is such an increase of the patenting activity. And maybe the most interesting question is what are the drivers of such an important increase? So if we look at the historical IP player activity through the years, what we can see from a player like Bosch, Denso, Valeo, or car maker like Ford or Daimler, is that some of them are showing an interesting increase of their patenting activity on the last 5 years. But when we look at their patent on the technologies that is asserted, what we can see is that most of their patents are related to ADAS application. And also they address very specific points of the LiDAR. So it could be, for example, improving the aperture, be more sensitive under rain or dirt condition. So it's very specific. And all these patents are related to really an incremental technology where you try to address very specific points of the technology. And because LiDAR, it's for automotive, it's an old technology, let's say, it's been investigated for a long time, and there is a lot of players with an important activity. Now the amount of white spaces in the field of LiDAR, and especially for ADAS application, is starting to be limited. And because of that, all these players have a limited capacity to expand or develop their RP portfolio. So this limited amount of white space will, in a short term, limit the IP activity of all these players that are mainly related to ADAS application. So if we want to think about an explanation of the fast-growing IP landscape that I showed in this previous slide, we have to look at other players than the historical player. And so if we look at the 5 last year, there is a lot of newcomers, and during this study we identify 3 main kind of new IP player. So the first kind of newcomers are new IP players that are new in the domain on LiDAR for automotive. So you have major companies from RF or semiconductor field like Qualcomm, LG, Ricoh, or Texas Instruments or BASF. And the interesting point here is that all these players are starting to move into the same direction, which is to reduce the size of the LiDAR and increase the speed of the LiDAR. And to do so, they really aim at providing non-scanning technologies. And also, with this non-scanning technology, one operation mode that becomes more and more frequent in the patent is the beam steering operation mode, which allow to have a very high degree of flexibility and seems to be the preferred mode of operation of all these players. So you have all these players that bring their knowledge in other domains and start to develop new technology for the LiDAR for automobile IP landscape. The other newcomers that are very interesting are pure IP players. So you have very famous companies that provide LiDAR. So Velodyne, Quanergy, LiDARtech, Lumina, on also some Chinese players like SI, Bowie Sensor, RoboSense, or Leishan LiDAR. And here what is interesting is all these players also adopt a same IP strategy, which is to publish patents that are highly specific and that target to assert their product. And so it's a very defensive strategy where the IP player try to assert their product on their application. And so all these players are very focused on specific aspect and specific product. And also what is interesting here is that all these players are involved in the robotic vehicle domain. And this is a good link because as this new player that provide the LiDAR are focused on the robotic vehicle, the last newcomers that appear in the landscape are autonomous car makers. And here we find a very famous player like Waymo, like Uber and Baidu. And this kind of player are really focusing on a higher level of patent solution, because here the LiDAR is not the main object of the patent, but it's the main technology where they build a full system in order to sense the autonomous vehicle environment. And so their patent are more related to the computing and the software and how to drive the LiDAR, how to sense the environment faster with more accuracy, but from software or from a system point of view, which is also something new that we haven't seen.
Thank you very much. So thank you all for your relevant presentation. We are now going to wrap up with a Q&A session. We'll answer as many questions as we can today, and we'll follow up via email for the remaining ones. So we've seen that we have a lot of questions. We will not be able to answer all today, but we'll follow up, don't worry. The first question is for Pierre. Are current autonomous vehicles safer than human-driven cars?
Thank you, David. So this is quite a tough question to answer. So we don't have full knowledge of where most of the companies are. The only thing that we get a glimpse of is through reports, mainly the disengagement reports from California DMV. So as far as we know, so Google also mentioned, he's doing a report every year. So they've driven 5 million miles, and in California, 300K miles last year. So they are doing, apparently they are doing very well with this disengagement rate, which is once every 5,000 miles. And the last month is even greater than 10,000 miles. So, if we compare to other companies, so maybe Cruise is just behind, but some other are struggling. We don't know so much about Uber that got a fatality, but there was a leak last year that mentioned 13 miles. So this is very low. I would not comment so much on Uber because they are not so transparent. But if we look at Uber, at Waymo and Cruise, it seems that their safety level right now is very, very close to a human driver. So by the computations I've done on my side, I think they are very, very close, and that gives me the idea that probably this year in 2018 they will be able to put more than probably in the range of several thousand vehicles. So I hope I answer.
Yes, indeed, tough question. Another one for you is: are current sensor sets used by AD players sufficient in respect to the safety?
So I will answer this one too. There is one thing in science which is you can prove something is not enough. When you have an accident, when you have something is not working, it's a proof. It's a proof it's not working. Okay, but you cannot prove that something will be safe, 100% in the years to come. There is no way you can prove. You can only test. You can test a number of miles and say, okay, I've driven, let's say, 100 million miles, and then I got no accident, so I feel like I can do it. So we see that Waymo and GM Cruise, they use the right approach where they incrementally increase the number of miles they drive, increase the number of cars they drive gradually as with their technology. And as the technology gets safer and safer, they put more cars on the road. And so it's true for cars, but it's also a way, each time they improve, I guess, they improve the sensor set, the technology set, the software, the computing. So it will be ever ongoing. It will never be enough. They will improve for the decades to come. So it will never be enough. I hope I answer again.
Okay, thank you very much, Pierre. We have some questions for Johan. So first question is, what is the reason that so many cameras are required? Couldn't one camera cover multiple angles and provide content for multiple algorithms?
This is a good question, and we have the complement, if I may, with the question from Julien Motin, who's asking for what about the architecture and about the centralization of the computing. Today we were talking about robotic vehicles, and in that case, centralization is here already. If we are talking more about ADAS, it's not true for everyone, for every OEM. So first, why so many cameras? We need cameras just to get more inputs, and if we have more inputs, we will have a better understanding of what is around the car, and it will be more precise. Then in the ADAS world, we can have some computing directly behind the camera, and with, for example, it's not always the case, but we can take some kind of Mobileye, for example, for pedestrian detection, which is plugged behind the cameras. And the more camera we have, the more information we have, and the safety and everything. The thing is that this is for decentralization idea. Now there is not really any consensus to say what is the best solution, and everybody is trying a lot of different things. So it's not a good answer for you, I'm sure, but it's yes and no for both of you. We can see both of solutions, and today there is not anyone who can say, oh, I got the good solution, and this is the way it should work.
Okay, thank you. Another questions? Are there autonomous system types that will be used to further prove out the technology while we are in the pursuit of the robotic car? For example, drones, Segway, or last mile delivery vehicles?
That's for software. If I can speak about, I will answer about software. For software today, we are still, as I said in my conclusion slide, we are still improving the software. So yes, if we are looking at drones, for example, and deep learning for drones, it's very some similarities with what we can see for the robotic car. The thing is that this software, as the hardware, it's true. It's true for the hardware too. For both, because the applications are not the same. They need at one point to be completely dedicated. For example, if you look for drones, you will have some object recognition, which will be a tree, for example, or you will have even gesture recognition, which may not be useful for robotic cars. So yes, it's a good thing today, but in the future, I think that path will be so different that software and hardware will be completely different for sure.
Thank you very much, Johan. Let's get to Paul. Paul, we have 2 questions for you. The first one, you mentioned that Bosch portfolio is mainly related to ADAS. However, Bosch roadmap ends up providing self-driving cars. Can you comment about Bosch IP strategy? Paul, are you there? Okay, so it seems that we're a small communication problem. Let's ask another question to Johan. Are the objective and progress the same in the autonomous trucks than in cars?
Of what I know, the objective for autonomous truck are quite different. As I said for drones and Segway-like vehicles and every type, even if we are talking about aircraft. About autonomous trucks, in terms of technologies and computing, it can be the same, but the objectives today in the research, at least for software, is not the same. They are more talking about platooning. It's just like a convoy of 2 or 3 trucks, one behind another, and to reduce the gas consumption. And their challenge is more about communication with the cloud, computing on the cloud, and this kind of stuff. I'm sure we will have some completely full robotic trucks, but for now, it's not, at what I know, it's not what they want to do yet. Thanks.
All right, thank you, Johan. Okay, let's ask another question to Pierre. Do you think the LiDAR will ever end up cannibalizing the radars?
So what we see right now is there is no technology that is taking over another one. I mean, this question, might be of better interest maybe for ADAS, but then I have a very different perspective on ADAS. I think it's really a stratified market that we will see in the future, and between like the level of each car, you either have the full set of technology or you have a reduced set, and the most reduced one would be just the cameras. So yeah, on the edge, you might see some competition between LiDAR and the radar, but I think it will be very limited in the ADAS space. And if we are talking about robotics, this I don't think so. I really think that most of the effort right now is on LiDAR and on cameras, and in between the radar is kind of a needed technology. But as I said again, it's mainly automotive grade. So there is, the market will be a little bit less attractive, I guess.
Thanks. The last question for you, Pierre. Yeah. It's concerning government regulation. When do you expect kind of time map for having regulation on autonomous driving?
Yeah, so regulation has been something that has been proclaimed as a key hurdle for autonomous driving. But as far as we see, there has been very little limitations. Actually, my perception is governments are quite racing to be the hub of such technologies. So we've seen what happened in the US, for example, and the regulation that was proposed a year ago was revised a few months ago in 2017. And is extremely light. So regulation in the US is not constraining so much. As far as Europe, I think they want to compete. So also, I guess they are giving permission as much as they can. But there are not so many players. That's probably why Europe is quite a laggard in this technology. And then China and Japan are extremely bullish in this direction. So again, I don't see much regulation, and probably most of the regulators will try to foster their own players as much as they can.
Good, thanks. We can take another question for Johan. Johan, it seems that there will be a long time when man-driven vehicles and robotic vehicles will be sharing the road. So are there plans being made to deal with this reality?
I'm not sure that there will be so long time. I mean, that we are already seeing some robotic vehicles on the road that are sharing the road. If we are talking about Arizona, California, for example, and everything is linked with what Pierre said about regulations. And I think that this is the bottleneck point of this. But what we expect, at least at Yole, it's that we will see that, let's say, in 2030, 2035. And the plans are made by OEM, by a service provider. If you should talk to people like Waymo or like Uber, Lyft, these guys, they already have planned to put vehicles, robotic vehicles on the road. At least in tests, in the 5 next year, we will see more and more cars like that. And in production, we can plan for 15 to 20 years.
Thank you. We'll try to reach Paul to ask again the question.
Can you hear me now?
Yes, perfect. So,
okay, cool.
I repeat the question. You mentioned that Bosch portfolio is mainly related to ADAS. So, do you think that Bosch roadmaps, which aims at providing self-driving cars?
Yeah. So as I said, it's a tricky question because Bosch IP portfolio related to LiDAR, it's a very big portfolio with many patents from device to system. What's sure is that regarding the LiDAR devices and the recent patent that have been published by Bosch in the last two years, their patents are more focusing on, let's say, classic approach, which means scanning technologies, one source, and also to reduce the size, but the performances and compared to what it's happening for autonomous vehicle are still limited, and so it's regarding the IP and the identified patents, it appears that Bosch is really focusing on ADAS application. However, as Pierre mentioned, there is more and more the gap between autonomous vehicle and ADAS application is getting smaller and smaller. And so also Bosch has also had some patents that are related to system composed of many sensors. And here they are addressing, for example, methods to address different sensors, different environments, and it could be used in autonomous vehicles. But regarding the LiDAR devices, I think Bosch are really more onto the ADAS than autonomous vehicle.
Okay, Paul, the last question for you. The solid-state LiDAR seems to be the next key technology. Do you have any idea of what kind of technology can speed up such sensor development?
So in fact, in the patents, there is already some technology that appears very promising because most of the IP players are now looking and describing patents using this technology. I think one key technology will concern the laser source, and we see more and more IP players looking at VCSEL technologies, for example, and also photonics circuits. So one big trend that we see is related to the laser source, and VCSEL have a very good shot in this field. Other than that, the trends are not so clear. It's more about the operation mode, and as I said, beam steering and beam forming appear very promising. And to do so, many players use an array of laser and an array of photodetectors. So all detectors that can be very integrated with a high density. For example, a single avalanche photodiode or a silicon multiplexer are also very promising technologies.
Thank you. Well, we have still a lot of questions. We'll follow up with you by email. So the webcast is ending. You will receive an email that will include the recorded session tomorrow. And feel free to share this link or to share the presentation with some of your colleagues. You can get more details and market information on our analysis on imicronews.com. In the report section, feel free to go there, and do not hesitate to contact us if you have any additional questions. You will find the appropriate contact in the last slide of the presentation. Thanks a lot for joining us. It was a great webcast, a big success. Have a nice end of day.
Thank you very much. Have a good day.
Bye.
Thank you. Goodbye.